Hey guys, we're looking at dividing powers for our laws of exponents. Again, just starting recapping what's happening here, what's going on with our laws of exponents when we're dividing, right? So this was the quotient rule from our notes. So anytime we have same base, I'm just gonna write out, I'm gonna color code, and you guys know how it is. We gotta color code our notes. Let me just get these ready to go. And then there's no black for some reason, so red. All right, equals. Okay, all right. So let's look this over now. Alrighty, so whenever we have same base, they're being divided. Remember what the pattern is we're going to be subtracting the exponents. Remember, key thing to remember is that the order matters. Order matters. Whenever we were multiplying, when we're multiplying the same base and we add, or we're, exponent to the power of another exponent, and oh my gosh, we're multiplying, right? So whenever we're multiplying or adding the exponents, it's called commutative, so the order doesn't matter, right? 2 plus 3 or 3 plus 2 is still 5, or 5 times 2 or 2 times 5 is still 10, right? So the order doesn't matter, but when we're subtracting, the order matters. 3 minus 1 is going to be 2 versus 1 minus 3 is negative 2, right? Those are two very different numbers on the number line. So the order is super crucial for this one. So we want to keep an eye out for that. All right, so it's always the numerator's denominator, the top number's denominator, minus the bottom. All right, so for here, it's a little different than what we've seen in class because we're kind of working backwards. We're given our answer and we're trying to figure out what the numerator was, but have no fear. We've got our formula. We can still plug it in and figure out what's happening here with the exponents, right? So what was going on here? We know that our answer is going to be, right, m minus n. So the numerator minus denominator. So we can kind of also set this up. So this is 11 to the power of numerator minus denominator is going to be equal to 11 to the power of 2. All right, and we're just going to take a pause. We're thinking about this. We're asking ourselves, does this make sense, right? So, okay, they got the same base. The base is all 11. What is our formula here? We take the numerator's exponent minus the denominators. Yep. And that's going to give us the answer that they give us. So something cool for exponents is when we set it up like this and they both equal each other and they have the same base, it's almost like we're canceling out the base and we're just focusing on now the exponents. So x minus 3, in order for these to be equal, x minus 3, the exponents need to be the same, right? Because the base is the same. So if they're equal, they're going to be this equaling the same thing. The exponents have to be the same, right? So we're going to try to like balance the equation. I'm going to fix this x because it's kind of driving me crazy. There we go. All right, we solve for x. Whoa, solve for x. We're going to add 3 to both sides. Add 3. X equals 5. And let's just make sure that makes sense. So 5 minus 3, it does in fact give us 2. So we'll go ahead and plug that in. X equals positive 5. Let's check. All right, let's try another one. This is looking more similar to what we saw in our class, right? Solving, simplifying, and writing it in the form of our base to the power of an exponent. We're not evaluating. We want to keep it in exponent form. All right, so this one, pretty straightforward. This is what we did in class. We're just plugging it straight into the equation, right? So it's going to be 4 to the power of numerator minus denominator. So 9 minus 5, right, should be 4. And we're not asked to evaluate. We don't want to know the specific answer. How do we know that? Because they're telling us in our instructions here, directions, that we want to keep it as 4 to the power of something, 4 to the power of something. So let's plug that in. So we're going to go 4. In order to do an exponent, we're going to have to click on this little math button. You can also plug in 4 from here. And then this guy here and this one. So you can kind of see it was already listed right there. This is going to be an exponent of 2, but we want an exponent of 4. So we're going to click this guy and then type in 4. So that way it does a little exponent. All right, so now we can check. And we got it. All right, and I believe the next ones are just repeats of the same thing. This is also something similar that we've seen in class, right? Remember expanded form? I'll go through this one as well. Expanded form, using these laws of exponents, we're kind of shifting away from expanded form because it's a little more complicated. But just like we did in class, whenever we're asked to simplify and everything's being multiplied out from in the numerator and denominator, we can cancel. So we're going to go ahead and just cancel out all the a's that they both have in common. Oh, we're only left with one a. All right, so this would be a to the power of 1 because they still want us to write the exponent. So a, or just a is fine, but we'll just make sure. A to the power of 1. All right, let me see. I wonder if they left it as a. Oh, they did. Okay, a to the power of 1. A or a to the power of 1, anything to the power of 1 of it is itself, so I'm wondering if it would accept it if it was just a. But I guess because they specifically said they want to know the exponent, we needed to include it. So just following, making sure we're following the instructions they give us. All right. If you guys have any questions, let me know. Email, text, and I'll see you guys later. Bye.